Assalamu alaikum and hello everyone. In this video we are going to study Riccati's equation. This is a nonlinear first order equation that looks like a more general version of the Bernoulli and linear equations we have already seen. It is a very powerful form often found in advanced mathematics and physics. Let's look at the standard form of Riccati equation, which is y prime plus 1 of x times y equals to b of x times y squared plus c of x. Notice two important things here. The first one is if c of x is equal to 0. This is simply a Bernoulli equation with n equals 2. Now, if b of x equals to 0, it becomes a standard linear equation. So, Riccati's equation is really the big brother of the equations we studied previously. Now, to solve this equation, we need one specific piece of information, a particular solution yp. In most exercises, this particular solution is given to you because it can be quite difficult to find it. Once you have this particular solution, we use the following substitution: y equals to the particular solution plus another function u, where u is a new unknown function that we have to find to write the general solution of your Riccati equation. Now, if we calculate the derivative of y, we obtain this. Now, when we plug this here and this here and here, and simplify the terms involving the particular solution yp, and cancel out because yp is a solution of our equation, we are always left with a Bernoulli equation in terms of u. I am going to show you this right now. Y prime is replaced by the derivative of the particular solution plus u prime plus a of x times y, which is our particular solution, plus u, equals to b of x times, here when we replace this instead of y squared, we have to use algebraic identities. Okay, plus c. Now I am going to expanding all this. X times yp plus a of x times u equals to b of x yp squared plus 2b of x yp u plus b of x squared. I need more space. I am going to do this. Okay, plus c. Now let's identify the yp terms. Look at this. Okay, equals to b of x plus c of x, which is our original equation in terms of yp. And we know that yp is a solution, then we can remove all these terms. Now we obtain another equation Okay, now I am going to write this in the left side. Okay, which is a Bernoulli equation. Now we divide by u power of 2. We can write this equals to b of x. Now we use the substitution by putting this equals to z to transform it into a linear equation. So by putting z equals 1 over u, we obtain z prime equals minus u prime over u squared, which is the same term here multiplied by minus 1. Then our equation becomes minus z prime plus this times z equals to b of x, which is a linear equation. To solve it, first we find the homogeneous solution, then the particular solution using the variation of the constant. Summing them, we get the general solution of the linear equation. Going back to our substitution, we get u equals 1 over z g. Then we return to our original substitution, which is y equals the particular solution which is given plus u that we replace here, and we finally find the solution for our Riccati equation. Now let's see how this works with a real example. Consider the following equation. Okay, and a given particular solution equals to x squared. First, we apply our substitution y equals the particular solution plus the unknown function, which is equals to x squared plus u. We calculate the derivative y prime equals to 2x plus u prime. We plug this here and this here and here. We obtain 2x plus u prime plus 1 over x times y, which is x squared plus u, equals to 1 over x squared times y squared, which is x power of 4 to x squared u plus u squared plus 2x. Now we are going to try to simplify. We have 2x plus u prime plus x plus 1 over x times u equals to x plus 2 over x u plus 1 over the cube of x times u squared plus 2x. Okay, we can remove this and this and this. I am going to write this in the left side, and we obtain this equation, which is a Bernoulli equation. Now we divide everything by u squared. we obtain this. We use the substitution z equals to 1 over u. We calculate the derivative, which is minus u prime over u squared. We have the same term multiplied by minus 1. Then we can write our new equation in this form. To simplify the next step, I am going to multiply by minus 1 to obtain this, which is a linear equation. Now we have to find for it the homogeneous solution. Solution of this equation, we can write it in this form. Then separating the variables, we get this. By integrating the both sides, we obtain the logarithm of z equals minus the logarithm of x plus constant k. Here we can use the exponential function to remove the logarithm, which is the exponential of the logarithm of 1 over x times the exponential of k. We put this equals to c, and finally we write the homogeneous solution in this form, c over x, because this is equal to 1 over x. Now we are going to pass to the next step, which is finding the particular solution using the constant variation method. We put zp equals c of x over x. Then we calculate its derivative, which is c prime of x times x minus c of x over x squared. I am going to return to take our linear equation and replace zp and zp prime by their values. Here we plug this here and this here. We can write it in this form: c of x squared minus 1 over x times c of x over x equals to 1 over the cube of x. We simplify it like this. Listen. Okay. We remove this and this. We multiply by x to obtain c prime equals to minus 1 over x squared. Then we integrate it to obtain c of x equals to 1 over x. I return to our particular solution. We replace c by its value, then the particular solution is equal to 1 over x squared. Now we can write our general solution for the linear equation, which is the homogeneous equation, plus the particular solution. I return to take the homogeneous solution plus the particular solution, and we can write it in this form by putting the same denominator. Now we return to our substitution, which is z equals to 1 over u. To find u, which is 1 over z, then we can write it in this form. Now we go back to our first substitution, which is y equals to the particular solution. So, okay, our first substitution was y equals to x squared plus u. We simply replace here the value of u to obtain our solution for the original Riccati equation. We finished our example. So, in summary, solving a Riccati equation is a three-step process. Step 1 is using the given particular solution to transform the equation into a Bernoulli equation. The second step is to transform the Bernoulli equation to a linear one. Then we solve the linear equation and we substitute back to find y, the general solution of Riccati equation using the first substitution. This concludes our series on the different types of first order differential equations. You now have a complete toolbox to handle these problems. Thank you for watching and bye.